Hello guys, welcome you all for this end-to-end session of AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot and we are learning a lot each and every day. Hope the same thing for you guys. So if you guys doesn't subscribe to our channel, please subscribe to our channel because like every day we are just posting a new video so that you will not miss any of our video, and also just press the notification icon so that you will get notified whenever we upload a new video. So guys, today we're gonna see the continuation of t-SNE. So last session we have introduced you what is t-SNE, how it differs from all other dimensional detection technique, and what are the advantages of t-SNE over other algorithms. Okay, so hope you guys have understand the session. So it's a continuation of previous session, guys. And one more thing, please make sure that you guys watch all the previous session videos so that you guys can able to understand what we are talking. Okay, because like that should be some continuation. Okay, so yeah, without wasting any time, let us jump into today's session. So what is the first thing that we are having is how does t-SNE work? Okay, that was the first thing that we're gonna have. Let's see how it is working. Okay, t-SNE works by calculating the pairwise distance between the data points in a high dimension. Then it uses the probability distribution to represent the similarity between the data points in the lower dimension space. Simple, guys. Okay, what it will do means, let us consider we are having a high dimensional data. It's going to be 100 dimension. Okay, consider any 2 points. There are going to be some distance. There is going to be some distance that is called as a pairwise distance. Okay, we're going to map the same distance of two data points in whatever the low dimension that we are giving. That's it. That is what t-SNE. Okay, not rocket science. Okay, let's move step by step. First thing, we need to calculate the pairwise distance between the data points in the high dimension. Whenever we are having a high dimension space, we need to calculate the pairwise distance between the data points that we are interested in. Then we need to define the probability distribution for the similarity in both high dimension and low dimension space. Okay, when we calculate the pairwise distance, it's going to give some value and we need to identify what is the probability distribution of that value. Then we need to minimize the callback divergence between these two distributions such that it is able to map the high dimensional data point to the low dimension. Okay, putting in a simple way, this is a dimensionality reduction technique, t-SNE. It is also able to map the high dimensional data to a low dimensional data. Simple thing. Only thing it does means it is gonna calculate the pairwise distance between the data point and tries to find the probability distribution and try to minimize it by using callback divergence, and maps the high dimensional data points similar distance in the low dimension. That's it. Okay, so this is what how the t-SNE works as a gist, and it is a black box of it. Okay, so yeah sir, over to you.
Yeah, so how does t-SNE work? So it will work by like first calculating the pairwise distance between data points in the high dimensional space. Then it will use probability distribution to represent the similarity between data points in the low dimensional space. So these are two characteristics like how it works. Step 1 calculates pairwise distance in high dimensional space. Step 2 defines the probability distribution for similarity in both high and low dimensional space. Then step 3 is minimize the uh, callback, okay, in, library diversion between the two distributions. So that is what it will minimize the diversion between two distributions. Okay, callback. So uh, this is a technique which helps it to do that. So these are three steps how it works. So let's move to the other section.
Yeah, sure sir. Yeah, now we're gonna see the parameters, hyperparameters in t-SNE. Okay, guys, we're gonna have a separate session of what is hyperparameter. Now let's understand hyperparameter very specific to t-SNE. Okay, the performance of t-SNE is influenced by several hyperparameters which need to be carefully chosen to achieve optimal result. Okay, I will say one thing. Okay, even though we will be like experienced in the field of data science. Okay, actually I'm having nearly like 4 to 5 years experience, sir has more than that. So whenever a new data thrown to us, right, we are a fresher. Okay, I hope like sir will also agree with me. Whenever a new data thrown to us, we are a fresher. Okay, so in order to handle the data and tackle the data with a model, we need to go for hyperparameter tuning. So each data set will have some characteristics. that is gonna be matched by using hyperparameter tuning only. Okay, anyone in this world can use machine learning model, but they doesn't know how to tune this hyperparameter. Only the person who are learning data science, right? They're gonna have an idea of, okay, this is what gonna be happening when I'm tuned this parameter. Okay, we're gonna have a separate session for hyperparameter. Hope like you're gonna have some more clarity of it. Now let us understand how it is specific to this t-SNE. Okay, perplexity. Okay, it is one of the hyperparameter. It controls the local neighborhood size in a high dimensional space, balancing between the capturing of local and global and local structure. Okay, we are moving from high dimension to low dimension, right? But we need to safeguard the feature of neighborhood sizes, that is distance. Okay, that is done by using this perplexity hyperparameter. Learning rate, it determines the steps size for the optimization algorithm, impact the convergence speed and solution quality. Okay, this learning rate I will explain in a simple manner. Okay, you are standing on a mountain, top of the mountain. Okay, you need to come down. Okay, if you jump, you will come down, but you will die. Okay, and if you give small steps, small step, you will come down, but it will take time. So you need to make an optimal step. This is called as learning rate. Okay, you need to find an optimal number of steps the model to run, so that you will get the optimal solution for your problem. Okay, it is purely depends on trial and error, guys. Okay, next, iteration, the number of iterations the algorithm runs influence the final output and the extent to which the algorithm has converged. Okay, it is also one of the learning thing, but like I will say this iteration is like how many times you need to tune your model so that you can get the best model out of it. Okay, so these are some of the hyperparameters that we are having in t-SNE, and very important. Whenever you change the value of this perplexity, learning rate and iterations, the model behaves differently. So you need to find a way where you need to fix your model such that you get the high accuracy. Okay, and everything is trial and error, but you guys now know the black box behind it, so that you guys are able to fine tune it such that you will get the maximum result for your data set. Okay, hope you guys are able to understand. I'm pretty sure like this is a thing that you guys need to understand when you are learning a data set, because like we are seeing, right, only 2 lines of code are necessary for loading the model and applying the model. But when you are learning data science, you guys need to know the black box behind it and how it works. Okay, that's the reason we are just doing this. So hope you guys have understand. If you guys have any doubt, just ping in the comment section, we will take up and we will solve your doubts. Okay, so yes, sir, over to you.
Yeah. So hyperparameters in t-SNE. Sorry. So we have hyperparameter tuning also. So that's a different. So here we are understanding hyperparameters in t-SNE. So the performance of t-SNE is influenced by several parameters, which needs to be chosen carefully to achieve optimal results. So there are three aspects which we need to consider hyperparameters in t-SNE. So one is perplexity, which is control the local neighborhood size in a high dimensional space, balancing between capturing global and local structures. So that is what we have to. So suppose like I tell you guys, so we also want to become global, right? Like people also become like they want to become global, but they remain local also. They always they want to remain localized with the tradition. They might use clothes of Western or global type, or might go and eat out and stuff, international brands and stuff, but they remain local. So same way, perplexity helps us to control the neighborhood size in higher dimensional space, balancing between capturing global and local structures. So there are cultural values, right? We balance between local and global. Similarly, this is a characteristics of like this is the characteristic of a hyperparameter in t-SNE. You can relate it. Okay, learning rate determines the step size for the optimization algorithm, impacting convergence speed solution quality. Okay, so this also, like, it optimize the algorithm, okay, impacting conversion speed and solution quality, all those things, so that the learning rate is well and stuff. That's another characteristic. Iteration, the number of iterations the algorithm runs influence the final output, the extent which the algorithm has converged. So, uh, iterations, perplexity, learning rate, these are very important aspects in hyperparameters in t-SNE. So, remember these concepts deeply so that while we connect dots, so you know we are connecting dots in application. So, you will know why we are doing something and why some outcome or result has come, and why we have to apply any concepts, what is the reason, why, what, why, and how. That combines in the application. So deeply understand what and why, so that you will apply properly, do all the assignments, do all the quizzes, and write to us if you have any question. So keep learning deeply with long-term objective functions so that you become world's best talent in AI ML data science or AI researcher or scientist. So keep learning. Thanks a lot. Let's see you in the next session.
Yeah, guys, let's move on to the next thing. Okay. Visualizing high dimensional data using t-SNE. Okay, this is what the major thing, right? The t-SNE is for visualizing high dimensional data. Okay, so t-SNE excel at a visualizing high dimensional data in a low dimensional space. It helps reveal underlying pattern clusters and relationship between the that might been hidden in the original high dimensional data. Okay, whenever you are having a data of higher dimension, whenever you visualize, the data set gets clumped and you are not able to understand any of the patterns. So that's the reason t-SNE is a very useful method which converts the high dimensional data to low dimensional data, such that you guys are able to extract the patterns and meaningful clusters out of the data set. Okay, let's see what are the things that we are having. Data exploration. Yes, t-SNE allows us to do EDA, that is data exploratory data analysis, to identify interesting structures and patterns within the data. Yeah, once you are having a low dimensional data, you can play with it. Okay, right? So that's the reason we can do EDA by using a t-SNE. Like cluster analysis, yes, t-SNE can help discover and visualize natural clusters in the data set, even in high dimensional data sets. Okay, because like we are going to convert into a low dimension such that we can do the visualization. Once we are visualized, okay, these are the categories that we are having, it belongs to this cluster A, and this is a category which is belongs to cluster B. Like that we can able to do the cluster analysis. Finally, we were having relationship visualization. t-SNE can visualize relationship between data points, helping to understand how different variables interact. Okay, yeah, true. Whenever you are having multiple features, right, you can use the t-SNE and combination of other plots so that you can identify how two features are related to other. For example, we are having a pair plot, right, in the cbot. Guys, if you doesn't know the pair plot, please go and watch the second session, I think so, third session of data visualization, where we have introduced you what is pair plot, how to interpret the pair plot. That's the reason we are just asking you guys, just go through all the sessions so that you can have a better understanding of what we are telling. Okay, so yeah, this relationship visualization is, yeah, in the same way. t-SNE use some other, together with t-SNE there will be some other graph which is able to represent the how different variables or features interact with each other using visualization. Okay, hope you guys are able to understand. So if you guys have any doubt, just ping in the comment section, we will take up and we will solve your doubts. Yeah, sir, over to you.
Yeah, visualizing high dimensional data using t-SNE. So we have to, like, in when we are using when we are visualizing data of high dimensionality, high dimension data using t-SNE. So in like t-SNE excels in the visualizing high dimensional data. It helps you, okay, load in a low dimensional space. It helps to reveal underlying patterns, which is the core essence of data science or AIML. We have to understand the underlying patterns, okay, clusters, relationships, which might be hidden in the original high dimensional space. Okay, so then there are three characteristics, which is data exploration. t-SNE helps allows us to explore do data exploration analysis to identify interesting structures and patterns within the data. Cluster analysis. t-SNE can help to discover the visualizing nature clusters in the data, even high dimensional data set. Relationship visualization. So t-SNE can visualize the relationship between data points, helps to understand how different variables interact. So variables interact, the interaction of variables, so that with visualization, okay, it helps us. So that's why it is very powerful for visualizing high dimensional data using t-SNE. Let's move to the other section. Thanks.
Yeah, sure, sir. Yeah, let's see the limitations and challenges of TSN. Okay, so every algorithm we are seeing, right? Okay, there are going to be some limitations so that we can get a better algorithm out of it. Okay, so let's see the same thing. What are the limitations and challenges of TSN? While TSN is a powerful tool, yeah, it is gonna apply it for a non-linear data also, right? I will say it's a powerful tool. Okay, it has some limitations and challenges that user should be aware of. Okay, crowding problem. In high dimensional data, t-SNE can sometimes exhibit crowding where data points are clustered together in a lower dimensional space. Yeah, it's true, right? When we are having 1,000 dimensional data, we're gonna represent by using only 2 dimension. This problem will occur, but like it is one of the challenge of TSN. Next, sensitive to hyperparameters, the quality of t-SNE visualization can be highly sensitive to choice of hyperparameters. Yeah, we have seen, right? Perplexity controlling, hydration controlling, and then something called as there are different things. Okay, so this kind of hyperparameter tuning gonna help, and it gonna change the complete value of t-SNE. Okay, we will see only there is 3 clusters. Once you change the hyperparameter value of perplexity, it gonna be 10 clusters. Okay, that's the reason. So it is very sensitive to hyperparameters. Next, computational complexity. Yeah, t-SNE can be computationally expensive, uh, essentially for a larger data set. Yeah, when you are having 1,000 features, the data set is going to be 1 to 2 GB. To run the data, t-SNE, what it is doing, it is finding the distance between 2 data points and gonna it's gonna convert. Once it find the distance between 2 data points, it's gonna convert from high dimension to low dimension and gonna fix it the same distance in a low dimension also as of in high dimension. This kind of operation has to be done by t-SNE. So for a larger data set of multiple columns, I will say multiple columns and then more records, it's gonna take more computation for us. Okay, and it's gonna take more time also. Okay, so these are the some of the challenges that are uh, having by this t-SNE. But like I hope like its advantages are more when compared to the challenges, but like you guys need to understand the challenges before working on this t-SNE, both the advantages and also disadvantages. So yeah, these are the, I will say, the challenges and limitations of t-SNE. Okay, yeah sir, over to you.
Yeah. So limitations and challenges of t-SNE, guys, while it's a powerful tool, okay, it has some limitations and challenges, okay, users, everybody should be aware of. So first is crowding problem, which is high dimensional data. t-SNE can sometimes exhibit clouding, uh, okay, where data points and clusters together in low dimensional space. So it can, okay, it can have this kind of problem. And then sensitivity to hyperparameters. The quality of t-SNE visualizing can highly sensitive to the choice of hyperparameters. Sensitivity is there. Then computational complexity, because it is it works with non-linear data. Okay, PCA works with linear data. So there are a lot of dimensions, okay, dimensions in the data. So the data might be complex. So t-SNE can be computational expensive, especially for large data set, because this technique is for actually for large data set and complex data, non-linear data. So non-linear data, usually if data set is large and non-linear, it can be heavy and computationally expensive. Okay, so that complexity will be always there. So let's move to the other section.
Yeah, sure, sir. I hope like you guys now able to understand. So previous session, this session, we have gone through the black box of this t-SNE. What is the advantages of t-SNE, how it works, and the limitation challenges, everything we have seen. Okay. Next session, we're gonna see the coding part. So this is all about today's session. So hope you guys have enjoyed. If you guys have any doubts, just ping in the comment section. We will take up and we will solve your doubts. Okay. So yeah, guys. Until next session. Bye, guys. Take care. We will all meet in the next session. Bye, guys.